Okay, so now we're going to look at identifying polynomial functions. Now they consist of either zero or a finite number of non-zero terms. These can be written in a form. We have the f of x equals the a sub n times x to the n plus dot 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 a sub 2 x squared plus a1 x plus a0. So if we think about this, is something like f of x equals 3x to the fourth plus 4x cubed minus 8x squared minus 4x plus 7. That could be our polynomial function, okay? Now, n is a non-negative integer, and each ai, so basically each of these numbers here, is a coefficient and can be any real number. Now, the key thing is our first one, this one here, on the highest term, which is this one, it has to be not equal to 0, because if this is equal to 0, then that's not our highest term. This one is our highest term. And so you always have to have a sub n, whatever it is, not equal to 0. Now, each of these things in here, the 7, the 4x, or negative 4x, the negative 8x squared, the 4x to the 7th, and the 3x to the 4th, those are each terms of a polynomial. Okay, so each one of them is a term. And so, this is the general form, but, looking at that specific one, we can kind of get each of these items. Now, what if we want to look at each of these and see, is it a polynomial? Well, first off, we want to have it in a form that looks something like this, or if you want the general form like this. Well, can we rewrite this? Well, yeah, that'd be negative x to the fourth and then plus x. So yeah, that would be in this format where their highest powers in is 4, and then we go down. What about this one? Well, I'm not going to go ahead and do it, but what we would have is we'd have an x times an x, and then this is x times x again, so that's going to be x squared times the x squared, so that's going to be an x to the fourth, and the only constant there is going to be a 2, so it's going to be 2x to the fourth plus dot 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 dot. I don't know what the rest of it is. I can just guess what those first one is because I know I'm taking x times x to get this one. That's x squared times x, that's x cubed, times x, that's x to the fourth, times 2, so it's 2x to the fourth. So my leading term is 2x to the fourth. And then it's just going to go from there. So yes, it is. Well, what about this one? Well, here we have x plus 1 in the exponent. We need x as a base, not as an exponent. And so this one, we can't do that one. Okay, what about this one? Well, this looks normal. This is almost exactly like that first one, except we're using a third and stuff. And so, yeah, that one looks like a normal polynomial. This one's just a normal polynomial, except for the fact that we can rewrite that as a power function. And so, because we don't have multiple terms, this one can be actually a power function. If you remember what a power function is, we go all the way back here. It's just k times x to the p, and so while we could think about this, this would be a monomial, or in this case, a power function, okay? Now this one, we can't really do anything here. This is like a power function divided by a polynomial, and that's not going to be anything in the format like we have here. And so just this one is just the wrong format. Okay, so this one could trick you up because a lot of people think about a monomial being a polynomial, but it's not. It's a monomial, and in the definitions, what we've done, it's actually the power function, okay? All right, so here we have the general form of a polynomial function. It's written in descending powers of the variable, which is what we need. And so, kind of like over here, we had 3x to fourth, and we had the third, then squared, then a 1, and then no x's. And then this one, we rewrote in descending powers. This is how a normal polynomial will be written in descending powers of x, and what we can do from there is we can look at it. So the term with the highest power is called the leading term. So this is our leading term. And from the leading term, we get the degree of the polynomial. Well, the degree here is 4, okay? And where a n x to the n is the leading term, the degree is n, and the leading coefficient is a to the n, a sub n. Okay, so that's everything we get. So we know n is equal to 4. We know the coefficient is equal to 2. And this is going to be greater than 0. So we know being even and greater than 0, we know the end behavior. Now, we can't say the whole end behavior because we don't know, but we know that it's going to come down and do something. And then over here, it's going to come down and do something else. Or if it's an odd, but we're doing it even. So I better not draw it that way because we're doing an even function. So I better draw the even. I don't know what I was thinking there. But for an even function, it's going to come down, and over here, it's going to go up. And inside of here, between here and here, I don't know what all of this right now does. We don't know what that does. So, it could go something like that. But then when it comes over here, the end behavior is going to behave like that. We know it's going to go up and it's going to go up because we have n is even and our k is greater than 0. So that's our end behavior. So we can do that. Now, that says here, the end behavior of the polynomial function will follow the same pattern as the power function in behaviors. The only thing we do not know is, again, is what happens between the ends, just that leading term, okay? And that's what I'm saying here. Anything could happen here. Maybe, it's just a straight line. Maybe it comes down first and then up. We just don't know what's going on in here at this point. And so we just know from the leading term that it's going to go up to positive infinity as x goes to negative infinity, and it's going to go up to positive infinity as x goes to positive infinity. Okay, so that's really all we can get from this out of the leading term. Okay, so let's look at these and see what we have. All right, well, our leading term, well, is it in descending order? Well, 4, 2, 1, nothing. So yes. So our leading term equals negative 2x to the fourth. So n is even, and k is less than 0. Okay, so even and less than 0, what does that tell us? Well, that means we know it's going to be something like this, because that's an even function, less than 0 for k. Now, do we really know what happens between here and here? No, it could do a lot of stuff, but we know that end behavior. Okay, so the end behavior is as x goes to negative infinity, f of x goes to negative infinity. Kind of a funny looking negative, but it's negative. And then as x goes to positive infinity, f of x also goes to negative infinity. So going to negative infinity both ways. All right. And that's all it's asking, the end behavior. And so that's what we would have to write for the end behavior. Now here, what about our leading term? Well, leading term here is 3x squared. Well, here n is equal to even again, and our k again this time is greater than 0. So here it was less than 0, here it's greater than 0. So that means we have something like this. But again, we don't really know what's happening in this area here. We just know that end behavior because it follows what that leading term is. So here we would say as x goes to negative infinity, f of x goes to positive infinity, and as x goes to positive infinity, f of x also goes to positive infinity. Okay, so that's just our end behavior. And we're getting this from our leading term. All right, so as it's written, is that a polynomial? No, it's not. What we need to do is we actually have to distribute that to make it a polynomial. And so if we do that, we'll have this times this. So that's going to give us 2x to the fifth minus x to the third minus x squared. Now, did we actually have to do all of that? Not really. We could have just done that first term because we know that's going to create the greatest exponent, and so that's going to be our leading term. So here, n is odd, k is greater than 0 because this is our leading term. All right, so with that in mind, what do we have? Well, if it's odd and it's greater than 0, it's going to do something like this. And so our end behavior is going to follow this. Now, again, what happens in here, we don't know. But we know that end behavior is going to follow whatever that leading term says. And so we're going to say as x goes to negative infinity, f of x goes to, well, it's going to negative infinity as well. And here, and as x goes to positive infinity, f of x goes to, well, it's going to positive infinity as well. And so that would be our end behavior for, this polynomial function, but overall this function itself, okay? Now, what about the next one? Well, now we know we're going to take 2 minus x times 2 minus x times 2 minus x 7 times. Now, what do we know about that? Well, we're going to really take a negative x and raise it to the power 7 because there's not going to be anything extra on that. And so if we take a negative x, raise it to the power 7, that's going to be, guess what? That's going to be our leading term. And we don't have to figure out what the rest of the terms are. We don't even care what all those other terms are going to be. That's beside the point. We just need that leading term, and that's going to be the highest power is going to be the 7, and it's going to have a negative because it's an odd number. Okay, so here n is odd, but k is less than 0. Okay, so what do we know about that? Well, if we flip that over, it's going to do something like that. It's going to go through our center, but I can't draw very well, so that's beside the point. And again, we don't know. Maybe at this point here, maybe it does do something weird like that. So we just only know that end behavior, and that's what we're worried about with this. And so here we see as x goes to negative infinity, f of x is going to go to positive infinity because it's going up. And as x goes to, now we're going to go to positive infinity for x, so f of x is going to negative infinity because it's going down. And so that is our end behavior for this function. And again, all we have to know is that leading term. And so all we had to do is multiply it out and we got it. And again, this one, all we had to do is really think about this one. Well, that's 3, 1, and 1, nothing. And so 2 and that's going to be the leading term. So we really didn't even have to do those two, but we did it just for fun. But that's the only term we really needed, that leading term. Okay, so let's pause there and I'll come back for more.